Greetings everyone, my name is Mark. I am a high school student and I am aspiring to become a quant. I enjoy math and finance, and I'm recording these videos mainly for my own purpose, because apparently when you try to explain something or when you try to lecture something, you remember about 95% of the things that you actually try to talk about and the things that you explain, whereas if you only go through your notes or read your textbook, you only remember about 5% of the things that you read. So for me to have a better and deeper understanding of these given topics, therefore I'm trying to explain them, at least to myself. And since that I'm already explaining it, I might as well record it and share it with you guys, and maybe someone will find it useful. I plan on covering multiple topics from simple mathematics to complicated quantitative methods, and today I'll be looking at the quadratic equation. Most of you probably saw the quadratic equation by now, since that you guys are watching this video. So to begin with, you've probably seen this the first time in school. This is how the quadratic equation looks like. This is the standard equation for it. ax squared plus bx plus c is equal to 0. This is the quadratic equation where the entire sum of the quadratic and linear and absolute terms are equal to 0, which means that you have all of your terms on the left side and you have 0 on the right side, where a, b, and c all belong to the set of real numbers, and a cannot be equal to 0, because if a were equal to 0, 0 times anything would be equal to 0. Therefore, you wouldn't have this term, and you would get a linear equation and not a quadratic one. So the quadratic equation, usually after being solved, has either no solutions, one solution, or two solutions. There we go, two solutions. The quadratic equation has no solutions in the case where there aren't any roots or any numbers which satisfy the equation. Or it can have one solution where the discriminant is equal to 0, or it can have two solutions where the discriminant is greater than 0, where the discriminant is equal to b squared minus 4ac, where a is the quadratic term and c is the absolute term. The solutions which you then get for the quadratic equation look like this, which is equal to negative b plus or minus the square root of the discriminant divided by 2a. There's a whole way how you can get to these solutions. You just play around with the equation, try to get all of your terms on one side and x1 and x2 on the other side, and so on. But I'm not going to go over that. I think it's interesting, but not everyone might find it useful. And plus, if it's just for your studies, this is the bare minimum that you need to know. So yeah, that's the formula for the discriminant. You might also see the quadratic formula instead of the discriminant underneath or nested in the square root. You might just see b squared minus 4ac. I personally like the discriminant. I think it's way cleaner. And yeah, that's about it to the solutions. Another important thing to mention about the quadratic equation is that you can write any quadratic equation in the form of a, where a is the quadratic term, times in the parentheses x minus x1, where x1 is the first solution, times x minus x2, where x2 is the second solution, and that all is equal to 0. For example, if we take the equation of 3x squared plus 2x minus 1 is equal to 0, well, you can rewrite that in this equation right over here. So first of all, what we need to do is that we need to figure out the solutions to the equation first. And we already know that you can do that with the quadratic formula, which is negative b plus minus the square root of the discriminant over 2a, where a is the quadratic term. And you can solve, I'm going to write it over here, you can solve the discriminant as b squared minus 4ac, where a is the quadratic term and c is the absolute term. So you can just plug the numbers in. So 2 squared, that's 4, because b is 2, so that's 2 to the power of 2, that's 4, minus 4 times a, which will be in this case 3. So that's negative 4 times 3 times c would be negative 1. And after that, that's negative 12, that's positive 12, that would be equal to 16. So the discriminant, oops, so the discriminant would be equal to 16, just like so. And now that we have that, we can just plug that in into our equation right over here. So x1 and x2 would be equal to negative b, which is minus 2, plus minus the square root of 16, which is 4 over 6, because it's 2 times a, and a is 3. So that means that x1 would be equal to, that's negative 2 plus 4, which is negative 2 over 6, which would be equal to negative 1/3. And x2 would be equal to negative 2 minus 4, which is negative 6. Negative 6 divided by 6 is equal to negative 1. So these are our two solutions. And we can plug them in into this formula, this equation, just like so. So a is equal to 3, and then that's x plus 1/3. Remember, it's always the opposite sign. X plus 1 is equal to 0, just like so. Another thing which is important to mention is that the solutions of the quadratic equation have certain relationships between each other. For example, x1 plus x2 is equal to negative b over a, and x1 times x2 is equal to c over a. So over here you have the same quadratic equation like from before. If you want, you can solve that one more time for yourself and try it out if it's, you know, and try it out for yourself to see if it's true. So there are three ways essentially how to solve quadratic equations, or three types of equations that you'll actually see throughout mostly school for the most of you. So the first type is where we're missing the absolute term. So in this case, what you want to do is that you want to factor out the x, so that's going to be 3x plus 2. And we know that when we multiply two things and they equal to 0, one of them has to equal to 0. So our first solution will be that x will be equal to 0, and our second solution will be 3x plus 2 is equal to 0. Subtract 2 from both sides, so that's 3x is equal to negative 2 times 1/3, and x is equal to negative 2 over 3. So that'll be our second solution. The second type of equation you can come across is where we're missing the linear term. So essentially we're missing bx from the equation. In this case, it's rather easy to continue solving the equation. So in this certain scenario, I would just add 21 to both sides. So that'll be 3x squared is equal to 21. Divide the whole thing by 7. By 7. That's the solution. By 3. Could have kept writing though. Divide the whole thing by 3, and that's equal to x squared is equal to 7. Then we want the square root from it. So the absolute value, as I mentioned in the last video, we covered irrational numbers. The absolute value of 7 is plus or minus 7, so positive or negative 7. So we're going to have two solutions, which is either positive or negative 7. And the third case, where we have all three of our terms, the quadratic, linear, and the absolute one. In this example, for example, x squared plus 7x plus 12 is equal to 0. What you can do is that you can factor out the terms, which will then equal to 0. So these are our parentheses. And now we know x times x will be x squared. So you just multiply this term right here. So that's x times x, which is x squared. And now we're looking for two terms when multiplied with each other. So here is a term that's going to be plus or minus. We don't know yet. Well, it's going to be plus because all of the signs here are positive, but you can have negative signs there too. And now we're looking for a certain combination of numbers when multiplied with each other that we're going to get this equation right here. So you have to be a little bit creative in this situation. So you need to think what times what would be equal to 12, but their sum would be equal to 7. Well, in this case, it's quite obvious. It's obviously 4 and 3. So if you multiply x times x, you're going to get x squared. Then x times 3 is 3x plus 4x, which is 7x, and then 4 times 3 is 12. So you'll just take these two parentheses, same story as here. If you have two terms divided, being multiplied by each other and they equal to 0, well, then obviously one of them has to equal to 0. So what you're going to do is that x plus 4 is equal to 0, and we can obviously see that the solution is negative 4. And for this term right here, this parenthesis right here, that'll be x plus 3 is equal to 0. It'll obviously be x is equal to negative 3. So those will be our two solutions. Another thing which I find very interesting about the quadratic equation, however, it's not that important and not that very well known, and it's not taught in school, but one thing that I think which is very, very cool, is that if you multiply the quadratic term with the absolute term and rewrite the equation as x squared prime plus 2x prime, because this is a different equation, minus 3 is equal to 0, you can actually continue solving the equation normally, as we've mentioned before. So, for example, it would be quite tricky to factor out the terms with the parentheses, which we've done before, if you have a quadratic term which is not equal to 1. You have to get more creative. So, for example, if you have this equation right here, you can, for example, do, so that'd be x times x, just like so. So that's x times x. And now we're looking for two terms, which then multiplied, we will get plus 2x and negative 3. So for example, let's try positive 3 and negative 1 is equal to 0. That should work. So that's x squared. That's negative x. That's 3x. Yep. So our solutions would be x is equal to negative 3 and x is equal to positive 1. But that's not the full story. These are the solutions to this equation right here. That's to the x squared prime plus 2x prime minus 3 equals 0, not to this one. So what you're going to do is essentially you're going to divide both of these solutions by the quadratic term, which is right over here. So x1 would be negative 3 divided by 3 is negative 1, and x2 would be 1 over 3, which is equal to 1/3. Thank you everyone for watching. That's all from me today, and stay safe.